Hello guys, welcome back to our channel The Engineer George. In this video we are going to cover big data analysis according to RTU syllabus, second to sixth unit. All we are going to cover in a one shot video. So let's get started. In this we have two subjects such as human engineering safety. This will be covered in many courses. So let's start with big data analysis. So firstly, I'm going to share all my notes as well. We have all the broad notes and also short notes also. All these, the form is in the link in the description as well as on the screen, so you can just go through that, fill the form, and I get the confirmation for transaction ID. So let's get started. So firstly we have this unit which is very easy and to score. So firstly there is an introduction about big data. Like firstly, what are we studying from big data analysis? So it means that we are analyzing a big data. Big data is a self-explanatory term that yes, we are dealing with huge data. It means the data which we are dealing with is very huge in quantity. It means it can be of very large files. So big data is something that is very huge. It's quantity wise very huge, so huge in number. Okay, then it's called collection of data that is in huge volume. So the collection of data, it doesn't mean that only a single data can be a very large, but we by name we can also conclude that it is going to be a very collection of various data. So we can say that it is a collection of various data which is huge in volume, which is very huge in volume. We are not going to say number because it is not a technical term. We are using volume, and you will see why we are using volume. So okay, so this is about big data, but what about big data analysis? The subject is big data analysis. So it is, analysis means to process it. Anything we are studying it deeply, it means we are analyzing it. So big data analysis is nothing but to analyze or examine the large data having variety. Okay, it can be example if we take Instagram. Why we are taking Instagram example? Because it has various of data uploaded, be it text, be it GIFs, be it live videos, text, images. We have every kind of data. If we analyze all this, so it will be called as big data analysis. So it is example of that. Example, every social media platform we can think it is it, because we are using ample of variety of data in that. We are ample of volume of data in that. So firstly we have covered all the what is big data, introduction of it. Now let's get into what its features. Now features of big data, if we can see in headline, features. So what we have concluded in that, in these 2 or 3 terms, it has more than 5 terms which starts with V only. So it calls as 3 V's of big data. It firstly is we are dealing with volume, and secondly we are dealing with variety, and thirdly, this is the most crucial effect why we are even studying big data, velocity. The big data is a successor of traditional file system. So what is before big data? What was that? So it was a traditional file system. It means that we are using a traditional or handmade like this to enroll all the data. Big data means we are using a technology or something in form of algorithms or program to store that. So okay, so if traditional was there, why we need big data? It because of this major reason, velocity. It means that how much faster I would be getting my data done or be processed or stored in somewhere, whether using a latency method or redundancy method. It means that I could save my money and time in form of speed in this data. And then variety, it means how much I can spend. In traditional system, you can only be used for one feature, variety of option in terms of JPG, .mp4 and doc or something else. Okay, it means that XML file or coded files is also stored in the same manner. And volume, it means that very large number it handles largely data. So these are its features. Okay, but we have talked about all the good things about big data, but still there are challenges also left in that. So let's talk about what are the challenges which we faced in using big data, in using of big data. So firstly, using big data, it itself is a very huge deal. It means qualified engineer to make such system. And firstly we will having major input in finding the company to trust on because of security issue. It means that we are handling all over our data. It means that every aspect of our data is within a hand of big data analysis or big data science or engineer. So firstly we will be facing some issues or insecurity measures that yes, our whole data is on the track. So secondly is insufficient understanding of data. It means that we need to like I have said, that big data analysis needs a good engineer to process all the data in one go. And then thirdly point, which challenge we will face is integration. Like how will all these three things will be, which platform will there, which program will be used, how many frameworks will be used, how did it will be working. So all these infrastructure or data integration is a big challenge. Like we are saying this, that yes, how cool is that, how very very good is that big data is solving this problem of traditional system, but on which cost? And is it there any of the measures or any functions that we can build so that our data would be stored there facing? And also it would be very 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 expensive. Why expensive? Because we are not for one data we are not making this, but we are making this for very much larger volume and variety and velocity of data. So it will be very very expensive. And also we can have some confusion regarding all the tools, like which tools we are using, which tools we need to use. We do not know that. So it means that also part of insufficient understanding that how we are using it and how we will be using that. Okay, so these are the two things, challenges and features. So these are the two things we covered till now, that features and challenges and problems with traditional large system. We also discussed that what were the features, were the problems with traditional large system, the 3 V's. Okay, then we have also, like I've told you previously, what are the sources? Sources are all the major big data having sites. It can be of social media, it can be of shopping websites, it can be of weather station, telecom company, anything or any aspect of a society which has been dealing with the loads of data is our source of data, big data. We have discussed 3 V's of data and types of data. This is a very important topic, because of that all our units are interconnected. So we will be let's see what are the types of data. You can be saying that there are types of data, it means that photos, media. No, this is not that type of data. Types of data means in big data analysis we are combined 3 types of data. Okay, firstly is structured data, secondly is unstructured data, and thirdly is semi-structured data. Now, what does it mean? What does these all means? So we have studied in data mining also structured data. What does it mean? If you're not familiar with this subject, you can also go to the this playlist, and check out those videos as well. So structured, it means that it's in a very formatted stage. It has very much formatting. So it means that it is containing in tables, because tables is the structured way to store data in cells. So this is the form type of data. It means structured. And unstructured means that it can be of any form. Example of photos, videos, and GIFs or short videos or MP3, or it can be of any form, like any form which is not structured. It means it can't be formatted out in a table. It means that it is unstructured. What is semi-structured? Now this is very important. Be very, very careful in this, and listen it carefully. So semi-structured data means that all our XML files and logmetric files or log files, it contains in this semi-structure, because in this we are having files with numbers, characters, and alphabet. So all these files cannot be filled in structured or unstructured, but these are called semi-structured. Okay, so by this half of our first unit has been covered. Now we will going into second. This is a very, very important, and most of the time one or two or both would be asked, and this is very, very important aspect of big data. So there are 2 file system. Okay, but why are we learning file system in big data analysis? While analysis of data, we use some systems so that our architecturally we are strong to manage the data. So these are 2 major system we will be covering in this unit. This is Google file system and Hadoop distributed file system. And we will be also comparing both of them. So firstly, let's go to Google file system. So by name we can state that okay, it is Google file system is made by Google, and it's some of the major points why GFS is mostly used and why it's so important. So it is also GFS is a scalable distributed file system. For why it's a scalable? Because of its largely distributed data for intensive application. Now what does it means that why scalable distributed, largely distributed data and for intrusive application? It means that wherever the hardware we needed is very, very compact, it means we do not have a very huge hardware. We are using this system there. It means that on our Android phone already Google apps are already installed and working, so intensively used. It means we are using them frequently, so it doesn't need a very much longer time to load. It means it satisfies the velocity criteria of big data, and also scalable means the volume aspect of big data, and velocity, volume, and variety, because it also have X, Y, Z, every type of data. So all these things are covered in that. So GFS is firstly a scalable distributed system for for large data, for it is used for intensive applications. And secondly, this is whole first point. And secondly, the major why we are using it because it provides fault tolerance while running. It means very less it is prone to fault. It means that we can't use something that is very faulty. We need something that is very quick, very having a large, can process large data volume, and also accurate. So it has the problem of inexpensive commodity hardware, and it delivers high aggregate performance to a large number of clients. It means that its performance criteria is very good. Because of its performance we are using it. And then because it provides a very familiar type of interface, and it doesn't implement a standard API, because it doesn't need a standard API. Okay, and also one of its feature is hierarchical distributed directories. It means that directories are in hierarchical format distributed, and they are identified as path names. I will tell you all this how it works actually as a form of diagrams. So yeah, that's very much it. So let's firstly we are talking about its architecture. So whenever you are answering this question, like tell us about or explain about GFS. So firstly, just for this 4 points which we have learned, that it is a scalable distributed system. Okay. Secondly, what we have learned is this because of its inexpensive culture, because it's very inexpensive. Okay. Thirdly, it doesn't it has fault tolerance, and also gives high performance. All these key points and how to answer the question are given in broadly and many aspects in the notes, so you can definitely check out the notes section and just click on the link and you will get your notes after or maybe the same time. Okay, then architecture, if we talk about, so firstly we have obviously who will use GFS. GFS will be used by clients. Okay, so we will have on the first block GFS clients. Okay, now in this we are having a clients will, what will clients do? Now clients will only have one task, that to request data. It means obviously if we are using any application, we are telling them, okay, I want to see this, we are requesting info, and to this block in which all the interfacing to the clients will be working, will be doing in this. So this will be called as master, and what master will be holding was the metadata. It means that data information will be there. It doesn't mean that it will show the data as well as, because we know data is stored in terms of bytes, so it will show the metadata. Metadata itself defines as the information of the data. Okay, now we will be having this will be connected to somewhere. Whenever the data is requested, somewhere or the other, the server, the actual server, will be affected or will be clicked by that. So firstly, these are called chunk servers. Okay, all this actual where will the data will be there will be in chunk servers, and there will be requests, and there is Linux file system which we using in chunk servers. So this is not in our like which we study, like what is Linux file system. This is something which is in which chunk servers used in GFS architecture file system. Okay, then this, if they are requesting, then they will be getting a response as well. Obviously, if I am requesting like on Google that I want this, who is the engineer George information, I have requested it. Now this will be showing to me many of the links, hyperlinks to my all the profiles, be it of YouTube, Instagram, LinkedIn, or something else. So when I click those links, so it will be getting all the chunk servers where the Linux file system will be there, and then my data would be shown to me as a response, like okay, the website will be open or something, the file document file will be open. So all these things will be happening. And also, in addition, if the clients are that if we are directly implying to the Linux file system, it means that we are requesting them to read or write, and this will be resulting in response again. It means that we are directly or indirectly can be read the data from that, big data from that. Okay, so the files are divided into fixed chunks, and these are the files, and these are in fixed chunks. Okay, and it is every aspect of these chunks are something unique. Okay, and then all this master contains all the files and information of that. So this is all about GFS. It's really easy, if we just study like this, like these three boxes, and they have data, we are requesting it, they are responding it. So it is very, very easy, and this is summed up of our Google file system. And then secondly is our Hadoop distributed file system. Now, if we are using very happily Google file system, why do we need to have this Hadoop distributed file system, HDFS? It is based on GFS. It means it uses the GFS concept of requesting a response, and it is also a distributed file system, as the name suggests, and it is designed to run on large cluster. So it runs on clusters. The new word we have learned is uses large number of that. Okay, thousands of computer will be designed to be running HDFS, to be running on them. Okay, so its third point is all the architecture we will be learning all that. So just be with me, and this is like the master/slave architecture. What is this? What is master architecture? We will be all be learning that in a short span of time. Okay, and this is split into that. GFS is split into many of chunks. It is on blocks. It is on very several blocks, splitted on blocks. Okay, and which are stored as set of data nodes. Okay, so before getting into HDFS architecture, first we need to learn what is this master-slave architecture and what is this building blocks. So master-slave is a part of this blocks. So it means that building blocks. Firstly is name node. Now this is our master of that, and we have seen in the GFS architecture the master block is there. So this is the master of building blocks of HDFS. Now name node is the main where all the data is stored. It means its functions as to direct the slave node there where the data is there. It means to give the direction, because why are our elders are important? Because they give us direction and they have a storing, keeping the track of how our files have been broken down. They keep the history and they keep the direction. So both of the things we are very necessarily needed for BDA. So this direct slave and also have the history of information stored. Okay, so after that, this is the most important aspect of this building block. Then it's the most crucial node, because if it fails, then whole Hadoop system, whole HDFS will fail. Okay, this, like, if the most elder or respected person dies, the family splits into pieces. So that's why this is the most major aspect of building blocks. And this second is the data node. This is the slave, known as slave of building block, the master and slave. Okay, but why the slaves are very important? Because it will host. It means that this is a beloved grandpa and this is a beloved servant of grandpa. Okay, now wherever grandpa goes, this will also go, and this will serve the grandpa, that if he is going outside, it will give them water or something. So it will host the data node, will be hosting all the clusters in that, and also not only name node but also all the family members, it will be hosting it. Okay, so after that, to perform reading and writing functions in HDFS block, so that it knows that where are the actual file located in local file system. And secondly, the client communicates directly. It means that wherever some guest comes, it doesn't go to the master or the grandpa directly. It have to communicate firstly with this data node or the slave. So firstly it will communicate directly with data node first to process the data, and then it can communicate with next or other data nodes to then replicate the data or the information. Okay, then thirdly, we are expecting a secondary data node. It means that there are many servants, but there is always a supervisor on the servants. It means that in our language, manager. Okay, so this name node. Okay, this is not data node. This is name node. Okay, so SNN will be a very important, because it monitors all the data nodes. It has only one job, to monitor data nodes, to monitor all the servants which are working on behalf of all the distributed system, and all the clusters which has only one manager or one SNN, and it communicates with the name node that this is the file, this is the report, and these are the salaries which we're giving, or some servants have been broken this. So this all the reports it's giving by secondary node to name node. Okay, to the masters, manager to master. Okay, then it also uses and utilizes the downtime. It means that the thing which name node has to do manually, now it can go to secondary node to do it for himself. Okay, it majorly do one task, that to monitor data nodes or to monitor slave nodes. Okay, Then these are something the people working. Okay, then fourthly, what are they on working? Okay, so then this is called known as job tracker. Job tracker, it means this is a link between you and your application. Literally, this is it of that. Okay, now after that we are having majorly this is it, if to understand that. And also this is only unique, only one job tracker is there, only one SNM is there. And then task tracker, last point of this. Task tracker, it means that master is overseeing all the overall execution of a job. Its responsibility is to its responsibility is to constantly communicate with the job tracker, to communicate job tracker. Okay, so these are the major 5 building blocks of HDFS, and now we can skip to the architecture of it. Like, what is the actual architecture of HDFS? Now, firstly, we are having a client, and client will, what will we doing? We will be assigning jobs. It means that it will be giving task to whom? To job tracker. And in job tracker, we have seen in this job tracker does only one thing, that is links you to your application, and that's the same thing. It is linking client to its application. Okay, supposedly this client has 3 application, so it does only one job, to linking you to your application. Okay, these are the applications. And in applications, what we are doing is there is a task tracker, because we have already learned that it communicates with job tracker. It means wherever job tracker will be there, task tracker will be there as well. And then this is also task tracker should be there, and would be there obviously, because if they are very very connected, they have to communicate with each other to let the application run successfully without crashing. Okay, so after that, what is task tracker actually doing? It means to communicate with job tracker, and it responsible to consistently communicate with job tracker, and it has the rhythm in the form of heartbeat to communicate. How will be the communicating? In the receive a heartbeat from task tracker within a specific amount of time. It will assume that task tracker has crashed if the doesn't receive a heartbeat, and it will not be, the corresponding task will not be performed of that. Okay, so after that, it is a master in overseeing all the execution of map reduce job. Map reduce we will be studying in second unit. But let's bear with me, and this is the 2 tasks, map and then reduce. This I will be explaining in great depth in the second part of this video. So after this, just skip to the unit 2 of this video. We are going to start with this only. So this is map and reduce function, which is using in task tracker. Okay, now these functions have been using by client sides, and after that, secondary name node comes into place. And we have learned that what does secondary name node do? It is a manager. Whom does it manage to? Whom does it reports to? It reports to none other than name node. It means the master. It reports to the master. This is the master node of name node, and name node always will be having job tracker. It means why? Because name node always be having some of the other job to be done, and we have seen that wherever job tracker is there, task tracker will be there. Okay, so then there is task tracker, and the data nodes, slave nodes, will be communicating with it. It means that the data will be on under the servants. This job tracker assigned all the servants their jobs. Task tracker and data node. So this is the architecture of Hadoop, and we have learned till there. Building blocks of Hadoop, need data, all this there, and then introduction of configuring Hadoop cluster. Like, what is this section? Let's go deep dive into it. So introducing and configuring introducing and configure Hadoop cluster. Okay, the majority of Hadoop settings are contained in XML files, which are to be configured. Okay, so in order to create a Hadoop cluster, we need to configure all the XML files. So firstly, for making clusters, we need to configure XML files. Okay, firstly we have to do the steps in order to move further in that. All the configuration files are stored in some of the directories of Hadoop. Okay, and this directory will be known as Hadoop default.xml. Okay, now this contains the default Hadoop settings, because if we do not have the settings of Hadoop, what will we do after that? So this is we having all the settings which will be used unless it is it's our default settings. If we want to add or change some of the setting, modify some of the settings, we can use an override in Hadoop site.xml. This is that dash. Okay, so our Hadoop cluster can be configured by one of the three modes of modifying the above file. And what are the three modes? It's literally in the course: local, pseudo distributed mode, and fully distributed mode. Okay, so we have already know that what is a this configuring XML file. We have just learned that how to configure that. Okay, now let's know the last part of first unit: local, pseudo, and standalone or fully distributed. Okay, so firstly is local. Local is also known as standalone. Okay, standalone mode. It is also the default mode of Hadoop cluster. It's when this is default XML file, and then if we just uncompress the Hadoop source packages, it consider our hardware setups. Okay, now this chooses to be very conservative. Okay, it means that default settings, it means that it will, example, this is a person who belongs to the 19th century, and it's does everything which is the tradition of 19th century. It means it doesn't go well with our generation. Okay, we use slangs, we use curse word as words, but this is a man of 19th century. Okay, it follows that cultures. Okay, it doesn't means that we ought to have follow all the rules. We doesn't it spells all the words right, doesn't use slangs, doesn't use curse word as today. So that's mean it is a someone of very, very strict or rigid or conservative background. So it is a very conservative factor of local Hadoop distributed mode, conservative mode. Okay, it can be not easily be changed or manipulated, and it also very minimal configuration will be used. That okay. So this is the major qualities of local standalone distributed mode, and all three XML files or Hadoop site.xml before the version are empty under default mode, because all this Hadoop site and all in this mode they are all empty. It means it will follow only the default .html file only. Okay, it means that very conservative, rigid. Okay, now after that, pseudo distributed mode. Okay, now it is running a Hadoop in a cluster of one with all the name nodes or building blocks running in a single machine. This mode complements the standalone modes. It means that it complements the standalone mode. Okay, then for debugging your code, you need to examine the memory usage of that. Okay, and third point is it has issues with input output of HDFS. Issues with input output of HDFS. And that's it. That's it for you to crumble upon, because it's last minute videos. Just crumble upon all this. And then fully distributed on, what does it do? It means that standalone mode, some of the feature, only one file is perfectly final for all the clusters, but fully distributed mode, an actual Hadoop cluster runs in the third mode. And a fully distributed mode emphasizes the benefits of distributed storage, distributed computing. It means everything is distributed. As the name suggests, all the distributed. What are the things which are distributed? Storage and computation. It means the power to store or usage. Okay, it is a production phase. Now this is a client can be also use that. Okay, this is memory efficient memory usage, and this is on production phase. Okay, data are used and distributed across many nodes. Okay, used and distributed. After that, okay, so that's it for this first unit of DVA. I will see you in the next video for second unit. Thank you so much for watching this video. Do subscribe and do fill the form to get all the notes. Literally nice notes I have made. So be tuned.